So here I'm using a small portable demo board from Load Slammer. I think they call this board Canyonville. And it's got 2 VRMs on it, so it produces up to about 1 volt at about 320 amps. We're not actually running 320 amps now, but it has a socket here, and that socket goes directly down to the power planes. And so here I just made a little 2-port impedance adapter so we can plug into the socket and get connections right down to the power plane. So let's take a look at what that impedance looks like. You can see it's a pretty flat impedance at about 700 microhms or so. For the most part, you can see how flat it is, which is a good thing. And here it's saying 686 microhms, so it's just about where it's supposed to be. You can also see on the board there's lots of little ceramic decoupling capacitors. And in a minute we're going to be able to see the impact of those decoupling capacitors. There's that impedance dip, and that impedance dip is the low ESR of the decoupling capacitors, the ceramics. And now it's going to become inductive, and that's the inductance, residual inductance of the power plane at the connectors. But you can see that's a pretty clean measurement of a 700 microhm active power plane using the J2161 splitter and the J2102B common mode coaxial transformer.